Welcome to Engineer Design, where we take an object and break down its individual components, provide them with brief but detailed explanations, and explain their functionality so that you, the viewer, can understand how and why this product works. So with that out of the way, let's get down to business. What we have here today is an air conditioner, but it's not just any regular air conditioner because it's powered by green energy from plants. Yes, the same plants that give you your daily supply of oxygen are also capable of powering an air conditioner unit. Pretty cool, right? But how is this possible? It starts with copper wiring and two rods. These are electrodes which will gather electrons. But where do these electrons come from? According to Professor Hamillers, the conversion of carbon dioxide creates organic compounds, some of which are used by the plant for its own growth, while some are eliminated through the roots by the microorganisms found in the ground. This process causes electrons to be released and harnessed by electrodes to generate electricity. The purpose of the copper wire and the rods are to transfer the electrons from the plant to the system through a socket or a battery in the form of electrical energy. The energy gathered is then measured by a multimeter. After the system is supplied with enough electrical energy, it will produce air using a direct current fan. The DC fan is powered by a fixed voltage value and consumes less energy, up to 70%, compared to the traditional alternating current fans. For the ventilation, the system will be using the same DC fan, and it is supported by a heat sink located at the back of the system adjacent to the fan. The heat sink acts as a form of thermal management, capable of increasing and decreasing the heat flow of the system. Since the heat sink releases air from the system, the AC unit's design is intended to be mounted in an area with an open space like a window, resulting in the entire system looking a lot like a window-mounted air conditioner. This is of course to prevent released heat from forming and spreading inside the room. A temperature meter or sensor will be utilized to identify and regulate the air according to the temperature of its surrounding. A switch will also be mounted on the front part of the system for its on and off function. The materials used for the system will be mainly composed of recyclable items. For thermal insulation, styrofoam will be utilized since it is capable of creating cold zones by trapping cold air and slowing down the progress at which heat enters the system. And for the system's structural support, recycled plastic bottles will be utilized to gain stability. And that concludes our engineer design. Once again, we are Dose Wizards, and it's been a pleasure explaining to you all.